Hello, hello. This next video on scientific notation, we are going to translate scientific notation into standard form. So you're going to need a piece of paper or your notebook and a pencil to take down notes and do the problems along with me in the video. So today we're going to go from a number written in scientific notation and write it in standard form. So just some key ideas. When writing numbers in standard form, the absolute value of the exponent indicates how many places to move the decimal point. If the exponent is negative, you're going to move the decimal point to the left. And if the exponent is positive, you're going to move the decimal point to the right. So what does that look like? Well, here's my first example. 3 and 22/100 times 10 to the negative 4. This is written in scientific notation. The first term is between 1 and 10. And then you have times 10 to the negative 4th power. So now how do I take this and write it as a regular number in standard form? Okay, so I'm going to write the first factor, 3.22. Now we know negative exponents indicate small numbers. So think about it for a second. I moved the decimal to get it here. Where did it come from? If I move the decimal to the right, am I making my number bigger or smaller? To the right, you're making the number bigger. Okay, so let me erase all this. As it says up here, when the exponent is negative, you're going to move the decimal to the left because watch what happens. I have 3.22. Now, if I move my decimal, here it is. How many times should I move it? 4 times. 1, 2, 3, 4. Here is my new decimal location. And then what should I put in these little loop-de-loops as placeholders? Zeros. 0, 0, 0. Now, you never leave your work like this with the loop-de-loops and your decimals all over the place. You're going to write it again. So my final answer to write this in standard form, I would write 0.000322. Okay, this is equivalent to this, which is equivalent to this in standard form. Okay, and again, I can check it by doing the opposite. Let's take this number and write it in scientific notation. Well, I would take my decimal and move it 1, 2, 3, 4 times, and since it's a super small number, my exponent would be negative. Perfect, we are done. Okay, again, I cannot stress enough, I can't handle it when kids leave this as the answer. This is like the showing of the work. This is your final solution. All right, letter B. Write 7 and 9/10 times 10 to the 5th in standard form. Again, take the first factor, 7.9, okay? And my exponent is a positive 5, which means I'm making a big number. So I'm going to move my decimal to the right for positive exponents because I'm going from 7.9 to now 79. So I'm making my number bigger. 5 times. 1, 2, 3, 4, 5. Here's my new decimal. And then I need placeholders in each of these loop-de-loops. Okay. So what is my final answer? What is this written in standard form? 7, 9 with 4 zeros. Okay, and now you have to add your commas to write it properly in standard form. So this here in standard form would be equivalent to 790,000. Again, this is the solution I would like to see. Let's do 2 more. Write 2.75 or 2 and 75/100 times 10 to the negative 3 in standard form. Okay, so let's write our first factor, 2.75. Now, negative 3 means I'm making the number small. So I'm going to go 3 times to the left or to the right. to the left. So 3 times. 1, 2, 3. Boom, 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 boom. I gotta input my zeros as placeholders. So I'm going to rewrite it as, well, let's put a 0 first. 0 and 0, 0, 2, 7, 5. Okay, make sure you could really see the decimal. All right, now let's try letter B. Write 6 and 38 hundredths times 10 to the 7th in standard form. So you're going to write your first factor. Sorry about my penmanship. Okay, and now I have a positive exponent, so I'm making the number bigger, which means to the right. So I'm going from 6.38 or 6 and 38 hundredths 7 times. 1, 2, 3, 4, 5, 6, 7. Here is my new decimal. And I'm going to input zeros into all of these loop-de-loops, placeholders. And then you are going to rewrite it again nicely. But actually I have it hidden right under here. So the first one, I've moved my decimal. Remember, again, you can check it. There's no reason to guess, did I do this right? If you do it the opposite of what you learned before, 1, 2, 3, we would get that instant scientific notation. And then even this one, if I'm here, 1, 2, 3, 4, 5, 6, 7, because again, you want a number between 1 and 10. So this last one is 63,800,000. The last thing I want to show you is, what does scientific notation look like on your iPhone, right? We all have an iPhone. If you typed in a huge number in your iPhone and then you times it by another huge number, hit enter. Your phone does not have enough space to fit all of the zeros that you want to. So your calculator or your iPhone will use scientific notation. So I just randomly put in a number and I times it by another huge number, and this is the answer that I got on my phone. 2 5/10 E 12. What the heck is the E doing there? Well, 2 5/10 E 12 is the same thing as 2.5 or 2 5/10 times 10 to the, can you guess the exponent? 12. Your phone just doesn't write 10 to the whatever power. It doesn't write this. It just puts the E. So it's 2.5 E 12. So you want to call it 2 5/10 exponent 12? Sure. Maybe that's why they use the E. I'm not even sure. Okay. Which then, if we had to write in standard form, we're moving it 12 times. 12 place values. So I'm going to write my 2.5 and then move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is your new number. Again, you know I cannot leave it with my loop-de-loops, so I'm actually just going to delete that and then go in and put my commas where they belong. Okay, so take out your iPhone and type in a huge number, multiply it by another huge number, and see what happens.